Hi everyone, myself Dr. Lakshmi, Prasad, working as an associate professor in the Department of Data Science in the Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about how we're going to construct the graph for data visualization. So here, if I'm going to consider a numerical data, so normally the data will be of two types like numerical data and categorical data. So if I'm going to consider the numerical data, so these are the methods that are available for construction of that. So for that, we are going to have order, array, and stem and leaf display. And similarly, we are going to have frequency distribution, cumulative frequency distribution. And for this, we are going to construct a histogram, polygon, and then okay. So these are the different types of methods that are available for constructing that numerical data. So in that one, we are going to see one by one. So how we're going to construct an order array, a stem and leaf display, and for frequency and cumulative distribution. So we're going to have the graphs like histogram, polygon, and then objects. So the very first thing is that sort a list of data. So which is going to shows the range, so min to max, and should also provide some signals about the variability within the range, and should also help the identity should help to help the identify outliers, and if the data set is large the ordered array is less useful. Okay, so ordered array is going to be considered which is going to apply in a sorted list of data and should also provide some signals about the variability, and we should also help to identify outliers, and if the data set is large then that ordered array should be less useful. That should be an drawback of this method. And suppose if I'm going to have a data like this in raw form, so then we are going to be arranging order array. So for that, what I'm going to do is that so we have to arrange the data in order varies from smallest to largest. So we have to be arrange the data in ascending order first. Then we're going to have a method called stem and leaf diagram. So the simple way to see this distribution detail set, right? So what we have to do that if we have to be separate the sorted data series into a leading digits, what we call it as a stem, and trailing digits, what we can able to call it as a leaves. So these are the different types of method where you can able to apply on this sorted data. Stem and leaf diagram. So the leading digits what we able to consider as the stem, and trailing digits what we consider as leaves here. So example is that, so here the data can be arranged in ordered array. So if I'm going to consider this number, then how I'm going to do that? So here 2 should be the stem and 1 should be the leaf. In 38, uh, 3 should be the stem, and then 8 should be the leaf. So like this, we are going to construct the stem and leaf diagram based on the data set what we have. So if it is a 10-digit number, so how we are going to construct it. So let's take another example. So this is the ordered array. So where the data is going to arrange in sorting order. So we have to be construct stem and leaf diagram for entire data set. So how can able to construct it? So for this, take the stem and leaves like this. Now to construct. So how we're going to construct? So if I'm going to construct this 20 series, so 2 as the stem, and what are the values? 1, 4, 4, 6, 7, and 8. So like this, we're going to construct the leaf values for the stem too. So similarly, if I'm going to construct 30, so what is the uh, 30 series data? So 30, 20, 32, and 38. So for this 30, so what are the leaves? So 0, 2, and then 8. And similarly for stem 4, so value should be 1. So like this, we are going to construct this stem and leaf diagram. So what are the other stem and units for the 100-digit number? How we are going to construct? So previous thing what I considered, this should be a 2-digit data. So now we're going to see how we're going to construct a 3-digit stem and leaf data. So in stem, if I'm going to consider 6 here, so in 3-digit number, so stem should be the 6 and leaf should become 1. And similarly for this stem, leaf should be 8. So we have to be round off to the next nearest number. And here in 4-digit number, the stem should be 12 and the 2 becomes the leaf. Okay, so like this we are going to construct the stem and leaf diagram for 3-digit data. So see the example, if I'm going to have a data like this, so 6 1, this is the data we are going to have. So how we are going to construct this stem and leaf diagram. So for that, so for the 6 series, so the data set is so 1 3 and then round up to 6, and 7 series, so for the 7, so 17, that should be 2, is also 2, and 5, and next one is 8, round up to next nearest number. And similarly in the next 8 series, so 8, for that 8, so 3 827, so 3 4 6 6 9 and 9. So we're going to construct for 8 series. So next thing, 9 series. So for stem 9, so 0 0.6 0.6, that should be 1 3 3 6 and 8. And for 10, so 1034, that should be 3 and 47 5 56 6. So like this we are going to construct this stem and leaf diagram for that given data for that 100 digits. And next one is that frequency distribution. So how we are going to construct this numerical data if I'm going to consider the frequency distribution. So frequency distribution is nothing but it should be a list or it may be a table, and containing the class groups and the categories or ranges within which the data falls, and the corresponding frequencies with the data falls within each group or category how to construct. So the frequency distribution is the list or table containing the class groups and corresponding class groups within which the data falls within each category. So that thing should be considered as the frequency distribution. So the frequency distribution is the way to summarize the data. So then we can also, this distribution able to condense the raw data into a more useful form, and we should also allows for quick visual representation of the data. So this one, so why are going to use this frequency distribution role means, so it should be summarize the data. So the data what I'm going to have, it is able to summarize the data, and second one, it should able to condense the data, summarize, and next one, condense the raw data into more useful form, and from that it should be allows the quick visual representation of the data. So that is the purpose of going to use the frequency distribution. And the class intervals and boundaries, so each class group having the same width determining the width of each interval. So the width of the interval should be the range that should be divided by number of desired class groupings. And we should also use at least 5 but not more than 15 groups. And the class boundaries never overlap, and round up the interval width to get the desirable endpoints. So here the We have to be use at least 5 but not more than 15 groupings, and class boundaries never overlap, and we have to be round off the interval width to get the desirable endpoints. So the frequency distribution, so manufacturer are going to have an example like the manufacturer of insulation randomly selects 20 winter days and able to record the daily high temperature. So for that, what I'm going to say that is, so this is the sample data we're going to have. So for a particular insulation company, which is going to take randomly 20 winter records, which should able to record the high temperature. And from this, what you have to do is you have to be find ascending order of the data. Then you have to find the range. So how the range is going to be done is as we have to be subtract the maximum value from the minimum value so that we can able to find the range, and we have to be select the number of classes. Usually it should be lies between 5 and 15, and then you have to be computed that class interval. So how the class interval is going to be done is that, so what is the range we have, that should be divided with the number of classes. So then I can able to get the class interval, then determine the class boundaries. So the class boundary will be 10, 20, and the class midpoints means in between 10 and 20 the midpoint is 15, in between 20 and 30 the midpoint is 25, and in between 30 and 40 the midpoint is 35. Like this, we have to calculate the midpoints, and we have to be count the observation and assign to the classes. So what I'm going to say that is, so if I'm going to have the data, so first step we have to be identify the range and find out the number of classes in between them. That means usually find the between 5 and 15 and compute the class intervals in between that. So that should becomes the range divided by number of classes, and determine the class boundaries, and then find out the class midpoints, and then count the number of observation and assign to the classes. And next one is that, so we have to be find the data in ordered array. So this is the data we have. So find out the frequencies in between 10 and 20. So the number of frequencies will be 12, 13 and 17. So and then in between 20 and 30, so 21 to 30, so the number of frequencies will be 6, and in between 30 and then 40, 40 it should be 5, and in between 40 and 50 it should be 6, 40 and 50, right? So 40 it should be 4, and in between them it should be 2. So once the frequencies are identified, then we have to calculate the relative frequency. So how this relative frequency is going to be obtained? So that we have the relative frequencies for particular this one is, so 0.15, and so how this one is going to be obtained? So the total frequency is the sum of all the frequencies 20. So how this one is going to get is 3 divided by 20, then it should be 0.5. So frequency by total frequency here 6 divided by 20, here 5 divided by 20, and this one 4 divided by 20 and 2 divided by 20. So like this we are going to obtain the relative frequencies. So from there we are going to obtain the percentages 15, 30, 25, 20 and then 10. So all the time the sum of all the percentages should be equal to 100. So for the numerical data, then we are going to have to construct the histogram. So how we're going to construct the histogram here? So the graph of the data in the frequency distribution is called histogram, and the class boundaries or class midpoints are going to be shown on horizontal axis, and vertical axis is either the frequency or relative frequency or percentage. Okay, so the graph of the data in frequency distribution is called histogram. So the graph of the data in the frequency distribution is called histogram, and the class boundaries or class midpoints are going to show on horizontal axis, and The vertical axis is going to have the frequency or relative frequency or percentage. So the bars of appropriate height is going to be used to represent the number of observation in each class. So we'll see how to construct the histogram. So we're going to have a class and class midpoint and frequency here. And so take the x-axis class midpoints and y-axis we have to consider the frequencies. So in between 10 to 20. So we have to be there. Number of midpoint is 15, right? So in this one, so 10 to 20. The class frequency is 3, so I have to construct 3, and in between 20 and then 30. So this should be 10 and 20, 30, 40, and 50. So in the for the class 20, what should be the frequency 3? So I have to construct 3 here. In between 20 and 30, the frequency is 25. So frequency is 6, and in between 30 and 40 it should be 5, and 40 and 50 it should be 4, and it should be 2. So like this we are going to construct the histogram. So we are going not maintaining any gaps between the each rectangle. That should be the example of histogram. If I'm going to maintain a gap space between each and every bar, then it should be treated as a bar diagram, not the histogram. So in Excel also you can able to construct it. So by going to tools, we are going to have data analysis. So by selecting this, we can able to select an option like histogram, and by click on that, we have to specify what should be the input range and all. And from that, we're going to be insert the data values. From that, we're going to be obtain the histogram. And frequency polygon here. So in this frequency polygon, what I'm going to say that is, so this is the data we're going to have, and how the frequency polygon is obtained. So in between this values 0 and 15, so this is the histogram initially what we have. So how we're going to construct the frequency polygon, we have to be join all the midpoints of the histogram, okay, by a straight line. So then I can able to obtain a polygon. So after removing this, so this like this we are going to construct the frequency polygon. Okay, so based on histogram only I'm going to construct the frequency polygon. And next one is tabulation. So cumulative frequency. So by considering cumulative frequency, so all this up to here we have that. So now how are we going to calculate the cumulative frequency? So cumulative frequency means so 3, and this should be add up with the next frequency. Then I'm going to get the 9, and this value is going to add up to the next frequency. I'm going to get 14 and 18. 18 plus 2, 20. And similarly cumulative percentage. So how the cumulative percentage is going to be obtained? So 15. So 15 plus 30, 45, 45 plus 25, 70 plus 20, and 90 plus 10. Then these are the cumulative frequencies and percentage and cumulative frequency of this one. So once you obtain this, then we have to be construct OGI. So OGI is going to be constructed on 100% cumulative percentage. So consider the lower boundary here and then cumulative percentage here. So less than 10 it should be 0. So mark it, and in between 10 and 20. So the cumulative frequency is 15. So 20 and then 30. And 30 to 40. The lower boundary value is 20 for 15, and then for 30 it should be 45, and 40 it should be 70, and 50 it should be 90, and 60 it should be 100. Okay. So once you joined all this, then you can able to get audio. So based on the cumulative frequency. And next one is this scatter diagram. So scatter diagram is going to be used for bivariate numerical data, which consists of paired observations taken from numerical variables. So here the scatter diagram is going to be is one variable which is going to be measured on vertical axis, and other variable is going to measure on horizontal axis. So scatter diagrams are going to be used for bivariate numerical data. So bivariate consists of paired observations taken from two numerical variables, and scatter diagram is one variable measured on vertical axis and other variable is going to measure on horizontal axis. So how this scatter diagram is going to be constructed? So take a volume of the data on the left side, a number of cost per day on right side. So take down the volume for data on x-axis and cost per day along on y-axis. So for this 23, so for this 23 the value cost per day is 123, and then 26 it should be 140, and 29 it should be 146, and 33, 38, 42, 50, and 55, 95, and 68 should be 600. So once you dot all these dots, then the diagram what we can able to obtain is that scatter diagram. So the scatter diagram we have to construct like this. So just marking the points on the XY plane. So how are we going to construct this scatter diagram in Excel means? So go to this icon, select the chart wizard, and I mark XY scatter plot. So my plots are going to like if you want to construct the column chart, bar chart, line chart, pie chart, and then like this scatter plot scatter diagram. So all the options are going to be available here. So by clicking that, you can able to select what type of scatter plot you want. Based you can able to get. And next one is that so what are the different types of charts available for constructing categorical data. So here categorical data, so we're going to be again divided into two tabs like tabulating data and graphing data. So for graphical data, we have to construct again bar charts, pie charts, and Pareto diagram. Okay, so these are the diagrams we are going to have for constructing the categorical data. So for this a summary of the table. So what is the data we have? So if everything is going to be in the form of the table, so instead of text, it should be the better visualization, and the variables are going to be taken out, and the values are going to be noted on in the form of table, so that you can able to clearly understood, and then can easily make the comparison between that. And see how we're going to construct this bar chart and pie chart. So bar chart and pie charts are often useful for the qualitative data, for the categorical data, and height of bar and the size of the bar slices can able to represent it. So if I'm going to have the data like this, so how we're going to construct the bar chart. So we are going to have the stocks and amount and percentages. So amount I'm going to construct on x-axis, what we're able to call it y-axis, and this investments type, so savings, CD, bond, I'm going to take an x-axis. So for this I'm going to demonstrate the amount and then bonds, CD, and savings. So like this we are going to do that. So the percentage of stocks in form, and percentage of bonds, and percentage of CD, and then savings. So we are going to do that. So the amount of dollars in the in x-axis and y-axis. This should be the column chart, row chart. And similarly, how we're going to construct this pie chart here is, so we are going to have stocks same table. Then how we're going to construct it means, so based on the percentage. So the percentage we are going to calculate it. Then I'm going to get that percentage. So make a pie circle, and then make a center, and then stock percentage 42, make an angle of 42, and then 29 bonds, and 14 for CD, and savings 15. Like this we are going to construct this pie chart diagram. pie chart example. That means uh, based on the application, what should be the better visualization, whether it should be bar diagram or it should be pie diagram, you have to identify. Suppose if I want to represent the data in the form of percentage, then I have to go for the pie chart. And next one is that a Pareto diagram. So this is the another kind of diagram. So to represent the categorical data. So here the categories are going to be shown in the form of descending order of the frequency. So the cumulative polygon is often shown in the same graph and is used to separate the vital few from the trivial mean. Okay. So the portrait Pareto diagram is used to represent the categorical data, whereas the bar chart where the categories are going to be shown in the decreasing order of frequency and cumulative polygon is shown in the form of same graph and is used to represent the vital few from the trivial mean. So this is the example of this uh, Pareto diagram. So here this should be where can a Pareto diagram. So the variables are going to be taken on x-axis and the percentage invested is going to be considered on both. So that means we have to construct the bar diagram, okay, and we have to construct the line diagram. So that should be the combination of bar and line you can able to construct as the Pareto. So see the example. So we are going to have investors. Previously, I'm going to consider only one investor. So now I'm going to represent the multiple investors. So this is the table we are going to have. So for the investor B for the stocks, it should be this one, investor B and investor C. The total amount of the stocks and what should be the total amount of the investor B. So for multivariate categorical data, we're going to do that. So for this, I'm going to side by side bar charts is the better one. So which is going to represents the savings I want to show for the investor A, investor B, and investor C. And what should be the investor ABC for the CD, and what should be the investor ABC for the bonds and the side by side charts the better one should be able to make the comparison in a better way. So let's take another example like we're going to have directions and then quadrants will have. So what should be this first quarter, second quarter values for three sales territories. So East Territory, West Territory, and North Territory. What should be the quarter values? So for the first quarter, the eastern side it should be 20.4, west and then north. So this should be the side by side chart diagram we are going to have for the better understanding. Okay, so these are the various types of diagrams we are going to be constructed. So for the categorical data. So for the very first thing is that we're going to have ordered array and stem and leaf diagram and then frequency and distribution. So where can able to see histogram, polygon, and ogive. So order array means where the data is going to be arranged in sorting order that should be in an order array. And once the data is ordered, then we have to apply the methods like stem and leaf diagram. So where the leading digits considered as the stem and trailing digits considered as leaves. And if by taking an example, so I should explain how we're going to construct this stem and leaf diagram. And similarly, I'm going to construct we're going to have a three-digit data. So what should be the stem and leaf diagram and frequency distribution. So here the frequency distribution is nothing but list or table where we're going to have the class grouping and corresponding frequencies. So for this class frequencies and class boundaries, we have to be constructed an histogram like so for constructing histogram we have to be know what should be the range number of classes and class interval class boundaries midpoints and observations, and this is the example I took and then how I'm going to construct this histogram. So by taking this example based on the class I'm going to construct the histogram, and but through Excel also I can able to construct by giving an option. We're going to have voting to tools and select the data analysis we're going to have a list of diagrams. So in that one, histogram is available. By putting the values here, we can able to construct the histogram. And the cumulative frequency curve, so it should be useful for constructing OU. And scatter diagrams is mainly useful for represent the bivariate numerical data. And these diagrams were simply kind of showing plotting the values on the graph. And by through Excel also can able to construct it by going directly to the chart type, and then can able to select different types of charts what we want. And next one is that representation of categorical data. For that, we are going to have the summary table and the graphing table. So through graphing tables, we are going to construct bar chart, pie charts, and Pareto diagram. So the summary of the table, what we have, everything should be represented in the table should be the better one. And then the bar charts and pie charts are mainly useful for present the categorical data. And by taking an example, I constructed how the column chart and row chart is constructed, and pie diagram. And Pareto diagram is another kind of diagram which is going to be represent a categorical data in the form of frequencies. So based on the cumulative frequency on the right side and the category on the left side. So this should be the combination of bar chart and line chart. Then how we're going to construct the multivariate categorical data. So for that we are going to have side by side bar charts is the better option for constructing it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.